Welcome back to the course on electronic packaging and manufacturing, and we will take off from where we left last time. We had talked about in the last lecture, we had talked about ball grid array packages. So, today what we will do is we will look into the next type of package or kind of package, area array packages again. It is called the LGA or the land grid array. Okay. So, the concepts that we will cover today, we will start with land grid array, and then we are going to talk about some other package configurations, and finally go to something called chip scale package and define what is called a package efficiency or packaging efficiency. Okay. So, these are the concepts that we are going to cover today, starting with LGA or land grid array. Okay. So, what is LGA? So, what we will do is first we will look at the definition and see what we are talking about. Okay. So, a land grid array, this is a definition from something called Technopedia. Let me first read this. A land grid array or LGA is an integrated circuit design involving a square grid of contacts. Okay. Typically, it is square, it is not necessary that it has to be a square. Okay. These contacts that are connected to the other components of the printed circuit board. So, if you look at just this first sentence, this is applicable to pin grid array, this is applicable to ball grid array. Okay. Now, this is where the differentiating feature of LGA comes in. The term, which means LGA, refers to a socket design where the certain components are disconnected from the actual circuit board and integrated into the board structure in particularly new ways. Okay. So, typically what we have seen, some features or components, what we have seen in a package is removed from there and put in the socket. Okay. The sentence is still not very clear, except that we understand in English what it means. Third one, in contrast to most other designs, LGA configurations have pins in the socket rather than on the chip. Now, this makes it clear. The pins or the interconnections are in the socket instead of on the package or the chip carrier. Okay. So far, what did we see? When we looked at a PGA, right, the pins were connected to the package on the underside like this. When we looked at a BGA, it was the same. Instead of pins, it was solder ball, which was in turn connected to the solder pads on the motherboard. But when we talk of LGA, these connections, in this case pins again, or also called LANs, are attached not on the package side, but on the motherboard side. So, that is the major difference. If you look at this picture, it probably is a little more clear. The package side, which is shown on the left, what do we see? What we see there are pads on the package side. These are not pins like a PGA, these are not solder balls like a BGA, but these are just plated pads, correct? And on the right hand side, what you see is the socket, and the socket has these pins. I do not know how clear it is from this picture, but it is a socket that has the pins coming out from it, okay, in a plane normal to the motherboard, and those pins are going to make a contact with the corresponding pads on the package side. On this package side, a pin over here is going to make a connection with a pad on this package side. The picture that you see on the right is a pretty well known package that came out of Intel probably more than 10 years back. It was known as the Intel 771 socket. It was a land grid array socket, okay, and it was used in some of Intel's Pentium microprocessors, LGA, land grid array. Now, how does this connection happen? I will otherwise, the next picture I am going to show you is this, where what you see is this is a one connector coming out of the socket. This is an FEA, finite element analysis. What you see coming out of here is one of the LANs, okay, and this is one configuration. Okay, it is not like it has to be like this, but this is how it is, and probably this plot I may be a little off, but probably this shows the stress, or this is a plot of the stress that is inside this at different points in this land. Okay. Now, what we will do is we will try to go to the whiteboard and I will try to draw how a land grid array looks like. Okay. So, let us say this is my motherboard, again I am drawing a connection here, and then I will use a different green to denote the package side. Okay. And then this has your whatever the silicon sitting inside, and then maybe this is a plastic package, whatever. Now, what do we do with the connections? The package side is going to have these pads. In pin grid array we saw pins coming out of the package, in ball grid array we had solder balls coming out of the package, but in land grid array we just have what you call these pads. Now, this is my socket. From the socket, what I will have, sorry, I will choose a different color. From the socket side, we have these connector pins or LANs coming out. So, now what happens is in a land grid array, sorry, let me, in a land grid array, you put some force and as a result what happens is these LANs press against these pads and the connection is made. And once you remove this loading force, then of course, the connection becomes loose and this package can be removed. Okay. So, what did we see? So, LANs or pins on the socket, okay, and pads on the substrate. Second is loading force ensures connection, and this arrangement like pin grid array is removable or detachable. Okay? All right. So, let us go back and again take a look at these two pictures and see what we just talked about. And here now you see this lever, there is a kind of a cover at the top. So, this lever leads to the loading force. As you pull it down, the package is pressed against the socket and the connections are made. Okay. All right. So, what you see is no solder joints or balls, uses lands and connection pads. The pins or the lands are on the socket side. And the other thing that I want to tell you is a land grid array compared to a solder or a PGA. Okay, these land pins are very thin, very much more delicate compared to the pins of a PGA. Okay. But this leads to lower use of lead. If you think about solder and all, this leads to lower use of lead, and so it can be designed for something called better ROHS. ROHS stands for restrictions of hazardous substances. Okay. We are going to discuss this later, but now also maybe I can make a mention over here that this solder typically consisted of lead, and now what happens is over the last decade there has been a push, even more than a decade I would say, there has been a push to go towards lead free solder. Okay. So, therefore, new solder compounds, new materials are being synthesized. Material scientists have been thinking about various formulations of coming up with lead free solder. You can imagine the impact of this, there is, the amount of electronic products, substances and therefore connections is enormous across the world. Now, if you have to change everything, it is a humongous task. Okay. So, but the industry is gearing up to that, and I think right now we are almost there, almost all new products today are made of lead free solders. Okay. So, restrictions of hazardous substances, that becomes important, okay, from environmental point of view. And to this end, LGA, when it first came up, this was a major advantage, that even if we have to use lead solder, the amount of lead that we are using is smaller. Okay. The advantages, these are thinner compared to PGAs. So, therefore, again shorter electrical paths, is thinner and lighter packages, LGAs allow for that, and ease of assembly disassembly, which we talked about. That is an advantage of any of these pin type of interconnections, whether it is LGA or PGA, and a disadvantage for a connection like BGA or ball grid array. Okay. So, that is LGA. Next, we are going to talk about some other lead configurations. Okay. That was lead, LEAD, PB, okay, the element. Here LEAD is lead as an interconnect. Okay. We have to keep all these in mind. Lead free solder, this is lead configurations, and then you also have the LID lid, which is the cover. Okay. So, whenever I use this word, just be careful, because they are all similar sounding, and every time I may not be spelling it out, but just keep in mind, be conscious and try to make out in what context I am using it. Okay. So, this is lead configurations in terms of interconnection or connections. Insertion mount. So, through hole mount, we have seen this before. You see this kind of package over here, the connectors come out only from one side of the package. Okay. Now, it could have been a serial 1 1 1 1 1 1, but to give it better mechanical rigidity and stability, you see that this connection takes a bend towards the left, towards the right, sorry, the next one takes a bend towards the left, and so you have this crisscross, one like this, 2 like this, then 3 like this, 4 like this. Okay. So, 1 like this, 2 like this, and then these pins go to corresponding holes on the motherboard. So, pin in hole type package, we have seen this before, and PGA, which is pin grid array package. Okay. So, again this is configuration in terms of, we have discussed this before, in terms of the interconnection method. This is pin in hole, the others are surface mount. So, we had discussed this before. Now, again now we know what is a ball grid array, that is a surface mount technology. Okay. Pin grid array also, when used with a socket like this, is a surface mount technology, because of course, it goes through, instead of holes on the motherboard, it goes into the holes on the socket, and now the rest of the motherboard is available to put more components. Okay. And the back side can also be used. It is typically not used because this is a very high density package. Typically it is not used, but can be used. It is available. All right. J-lead package, Gullwing leaded package, leadless chip carrier, we have discussed all this before, and now we have added on surface mount what is known as the ball grid array. So, as you see, the BGA is connected on this side of the motherboard. So, it is mounted on the surface, and each of these, as said before, also presents the reverse side of the surface for placement of other components. So, that is the advantage of surface mount technology. Surface mount technology is also often called SMT, surface mount technology, very commonly used term. Okay. Let us move on to the next slide. This one is known as the chip scale package. What is a chip scale package or CSP? We will just briefly discuss each of these a little bit. The CSP stands for, a chip scale package means that the size of the chip is comparable to the size of the package. The package is less than 1.2 times the size of the IC. Let me take this example again, this damaged package that I showed before while exhibiting ball grid array. Here what you see, this shining part in the center, that is the silicon chip. This is the silicon, and then this green square, that is the package. So, you see that the package is significantly larger than the piece of silicon, correct. So, if you want large number of interconnects, then you need a larger package, you need more number of solder balls or pins or lands. Okay. Chip scale package, on the other hand, the package is less than or equal to 1.2 times the size of the integrated circuit, which is the piece of silicon with all the circuits inside. Okay. So, obviously, it cannot be used in high end servers where or even high end desktops or even any of the computers like laptops. But however, if you think of the personal digital assistants, the cell phones, the tablets. So, here these chip scale packages are important. Why? Because of two reasons. One is, first of all, chip scale package is possible because these are nearly not those high density packages, these do not have as many features or as much of computing horsepower. So, that part is good, it allows for that, it does not require that amount. And why we put it is because these are products where there is severe space crunch. Okay. There is not enough space to accommodate a large number of components. So, here if you can come up with chip scale packages, it helps. Okay. So, the greatest advantage is size reduction, okay, no questions about that. However, CSP, just the term CSP, chip scale package, does not give you, apart from this, does not give you much idea about what is the construction. So, there are several types of CSPs as we see here. I am not going to talk in details about each of these. Okay. Maybe if time permits, we can come back, but CSP, these are different kinds of advanced packaging techniques. This course is very fundamental. So, we will not go to the advanced packaging technologies, but these are some of the examples where chip scale packages are possible. Okay. These are also types of CSPs, again the same things that are being shown here. Several examples: flex interposer, rigid substrate, lead frame and wafer level. Wafer level, just let me tell you, just give you a brief idea of what wafer level is. Here actually the interconnections, whether it is solder balls or whatever, happens right on the wafer. It is even before dicing the wafer into small dies, okay. And then along with that it is after this assembly it is cut and put on the package or on the motherboard. That is called wafer level assembly, all right. So, we are, as I said, I will just flash this, I will keep this on the slide. Okay, by the way, this I forgot to mention the source. This is from the book from Rao Tumala, Fundamentals of Packaging, Fundamental or Microelectronics Packaging, sorry. Okay. So, there is a definition of what is called a packaging, or there is a expression called packaging efficiency, which is this: efficiency is IC size over package size. Okay. And if you look at some of this example, dual inline package, that is huge. The package IC is only 2% of the package size. Quad flat pack 5%. If you go to ball grid array or CSP, that is 30 to 80%, CSP especially, as I said 1.2 times. So, it has to be better, more than 80%. And bare chip, if you just take it and put it on the motherboard, no substrate, nothing, direct bonding of the of the piece of silicon directly on the motherboard, that is 100%. Clear? That typically, as of now, if you are wondering how is it possible, because from the chip I have to take out these connections to wire bonding on the leads. So, till now whatever we have discussed, a bare chip with 100% packaging efficiency we have not seen, and based on the technologies we have discussed so far, it is not possible. But in the next class we are going to talk about a technology called flip chip, and in there we will see that how a bare chip connection directly on the motherboard is possible, and in which case the packaging efficiency would be 100%. Okay. So, that kind of brings us to the end of this lecture. What next? The best package is no package at all. Okay. So, can the manufacturer ship the chips with BGAs or flex connectors on the test and burnt in wafer? So, as I was talking about, can you have the connections directly on the wafer, and this is called the wafer level flip chip. Okay. So, that looks like a trend right now, or has been a trend actually for some years. Okay. So, we will discuss a bit about this, especially when we talk about flip chip. All right. So, for now, thank you very much, and we will continue this in the next lecture. Thank you.